about the heat transfer in the various process like the constant pressure process, constant volume process, isothermal process, adiabatic process and the polytropic process. Today we will discuss about the three process: constant pressure process, constant volume process and the isothermal process. And we can prove the specific heat at the constant pressure minus specific heat at the constant volume is equal to the characteristic gas constant R. We can prove from this constant. Now, the constant pressure process, we know the very well from the first law of the thermodynamics, dQ is equal to change in internal energy plus PdV work. Now, we can put the P in the inside like this. If 2x is equal to 2d of x, we can write like this. Now, this P is transferred to inside. dQ is equal to du, this d, and P is entered the inside. Now, this dQ change in the heat transfer is equal to, यहाँ से d हमने कॉमन निकाल लिया. This term is U plus PV, and U plus PV is known as the enthalpy of the system. Enthalpy of the system H. This dQ is equal to d of H. The dQ is equal to d of H may be written in the form of the mCp delta T. mCp delta T is the heat transfer at the constant pressure, mCp delta T. This is the constant pressure process, right? Now, the constant volume process, this process is also known as an isoporic process. That means the volume change will be the zero. That means the volume is a constant, volume change will be the zero. This term will be the zero. That means dQ is equal to the change in the internal energy, and this term may be written in the form of the mCp delta T, mCv delta T. CV, that means specific heat at the constant volume. In the constant pressure process, the specific heat at the constant pressure. Now, the third process is isothermal process, and isothermal process is known as a constant temperature process. We know very well the constant temperature process. That means the temperature is dependent on the internal energy only. The temperature is dependent in the internal energy. That means U is the function of the temperature. U is the function of the temperature. That means the temperature will be the constant, U also will be the constant. Now, this dQ is equal to the only dW. Given the another relations for the isothermal process. Now, we can prove the specific heat at the constant pressure minus specific heat at the constant volume is equal to the characteristic gas constant R. You know, the enthalpy. Enthalpy is nothing but it is the summation of the internal energy and the product of the pressure and volume. Now, change in internal energy. The change in internal energy is equal to the change in the enthalpy is equal to the change in the internal energy plus dPV or PdV. For an ideal gases, this PV is written in the form of the MRT. You can write PV is equal to MRT. DH is nothing but change in the enthalpy. The change in enthalpy from the equations number 1, DH may be written in the form of the mCp delta T. This DH is written in the mCp delta T. Like this change in internal energy may be written in the form of the mC delta T. This time is a CV and this time is a CP. From the equations number 2, dQ or du is equal to the mCv delta T. This du is equal to mCv delta T. Now, this PV can be written in the form of the mRT. That means this D, change in the pressure and volume, means mR delta T. Right? For the same mass and same temperature, we can cancel this whole term m or delta T. This is Cp, Cv and R. The Cp is equal to Cv plus R. That means R is equal to the Cp minus Cv. Now, we know very well the adiabatic index. Adiabatic index is nothing but it is the ratio of the specific heat at the constant pressure and the specific heat at the constant volume. This is the adiabatic index. We can write in the term of the Cp, the value of the Cp in term of the gamma and Cv. Cp is equal to the gamma into Cv. Now, R is equal to Cp minus Cv. We put the value Cp. Cp की वैल्यू यहाँ पे पुट कीजिए. This R is equal to the gamma Cv minus Cv. Now, Cv is common. Cv is common. That means this gamma minus 1 will be written. Now, Cv. What is the value of the Cv? Cv in the term of the R over the gamma minus 1. This is the expressions or relations for the Cv and R and gamma. Now, this value Cv is also equal to the Cp over the gamma. Cp over the gamma. Put the value Cv in this equations. Cp over the gamma is equal to R over the gamma minus 1. We can calculate the value of the Cp in term of the gamma and R, and we can calculate the value of the Cv in term of the gamma and R. And this is the important relations for the adiabatic process. Thank you.